Hi guys, it's time for some whole number multiplication and division. So first, let's define multiplication. Then we're going to talk about the terminology, the properties, and the models we use to teach it. We'll do the same thing in a few minutes for division. But first, what does multiplication mean? So we're going to take two non-zero whole numbers, and we're going to find A times B by adding A copies of B together. And that's what we do if A isn't 0. And if A is 0, we just say the answer is 0. So some examples. 3 times 4, we're going to add 3 copies of 4 together. 2 times 7, take 2 sevens and add them up. Now 7 times 2 is a lot longer. We're going to take 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. A total of 7 2s, I hope. And lastly, multiplying by 0 by definition is always 0. You could think about taking no copies of 5, or 5 times 0 would be 5 copies of 0 and adding them up. Pictures do help, and I remember seeing these in first and second grade math books that I used to check when I had a daughter in Chugach Optional. And they'd have pictures of bananas. I'm sorry, I don't have anything as fun as that. I just have pound signs. So you can see I have 3 rows of 4 pound signs each. And so this illustrates 3 times 4. And I'm pretty particular that I'd like you to make the first number be the number of rows. So you have 3 rows of 4. It's going to help them when they learn matrices in middle and high school or go to college that you always put the row number first and the number of columns second. So the terminology, if A times B is C, A and B are called the factors, C is called the product. You should know these. Properties. So I've broken these properties into a lot of slides, but we'll go through them relatively quickly. Commutativity, you might remember from adding, it tells me whether order matters. If it's commutative, order won't matter. So I've drawn a picture here for 2 times 3. There's 2 rows. Each row has an asterisk, a pound sign, and a dollar sign. And so that's 2 rows of 3. That's 2 times 3. And then I could count. There's 1, 2, 3, 4, 5, 6. Or if I turn my head, I could look at this and say, oh, I see now sideways 3 rows of 2, which would be 3 times 2. So 2 times 3 equals 3 times 2. Multiplication, like addition, is associative. You can move the parentheses when you only have multiplication and it doesn't really matter. And I'm really sorry I did not draw this. I'm not still very good with this technology, but here's how you could illustrate it. You could think about making this kind of a rectangular block. Think of it as having 2 rows, each row one on top of the other, or layers, would be a 3 by 4 block. And that would be 2 times 3 times 4, but you'd pick it up in your hand, you'd turn it, and suddenly you'd see 4 layers, and each layer was a 2 by 3 rectangle. So you could see that 2 times 3 times 4 is equal to the quantity 2 times 3 times 4. The multiplicative identity, what number, when you multiply by other numbers, always gives you the other number back? Well, the answer is 1. So that's called the multiplicative identity. It lets the other guy keep the identity. And the 0 property just says multiply by 0, you always get 0. And finally, whole numbers are closed under multiplication. It just means multiply 2 whole numbers. The product will always, always be a whole number. And we have one new property that's going to blend multiplication and addition. And hopefully I will remember to fix this slide. It should say A times B plus C equals A times B plus A times C. So I've taken an example. This is a big long rectangle. It has 2 rows and 3 plus 4 columns because there's 3 blue columns and 4 green column. So this is 2 times 7, but I could break it up into 2 times 3 and 2 times 4. That's the idea of the distributive law. There's a pair of distributive laws depending on the order, and the other distributive law says that A plus B times C is what? So you should think about that. Now let's look at some models. The first two are the array or area model, and they both talk about rows and columns. In an array, you have separate objects. So I've already given you an array model with the pound signs, or the one that used the dollar signs and the asterisks. That was the array model for 2 times 3, or the ones with the pound sign, I think was 3 times 4. If you join it up so it looks like a solid rectangle, that's the area model. And A times B will be a rectangle with A rows and B columns, and the area is what is A times B. So this is a great model. I love the area model because you can use it to teach so many things. We are going to use it when we talk about fractions. We're going to use it when we talk about decimals, percents, and you can even use it to talk about multiplying together polynomials, which we may or may not get time to do, but by the time you see it, you'll go, oh, same old area model we've done a gazillion times. So I've just drawn one little picture. 2 times 3 is 6 because this rectangle at the bottom of the page has 2 rows, 3 columns, and you count the little squares and there's 6 of them. The repeated addition model just uses the definition. 3 times 5 is 3 copies of 5 added up. The number line model, to find 3 times 5, you start at 0, you move to the right 5, a total of 3 times, and you'll look at where you end up on the number line. You end up at 15. That's the product of 3 and 5.